Number systems 8, working in scientific notation. The slurring target number 4 is we are going to compare quantities written in scientific notation. So we're going to compare if one is larger than the other, or if one in the storyline case is what pepper is hotter than the other, or how much times hotter. So we're going to get going here. So the first thing we're going to look at is we're going to use the symbols. This is less than, is this one, greater than, is that symbol, or equal to compare the quantities written in scientific notation. It says adjust the mantisas and the exponents to either have the same exponent or mantissa and rewrite the adjusted number in scientific notation. Do not change it into standard forms. In other words, do not work it all the way out. So we're going to look at the first one, and I prefer having them as the same mantissas, or I should say in correct mantissa form. So my number is between 1 and 10. So this first one, I'm going to move this decimal over to my left to put it in correct scientific notation form. So it's going to become 5.95 times 10. Well, right now it's to the 4th, but I move that decimal over once to the left, which means I'm going to add 1. So this becomes 5 hundredths times 10 to the 5th. Now I'm going to look at the other one. This time, I'll write it out so it's a little easier to see here. This time, I'm going to move the decimal to the right one because I want it to be 5 and 95 hundredths times. And if I move something to the right, I actually subtract from the exponent, and since I only moved it 1 to the right, I only have to subtract 1, which make it times 10 to the 6th. Now I'm ready to compare, since they're in correct scientific notation. I notice that the mantisas are the same, so then I'm going to look at the exponent. And since this exponent is 6, which means I'm going to multiply it times 10 6 times, and this one is 5, that means I'm going to multiply it times 10 5 times. Well, then the 6 times is 1 more, so this is greater than, so I'm going to put my greater than symbol. So in other words, when I read this, maybe I'll put it down here, 5 and 95 times 10 to the 5th is less than 5 and 95 times 10 to the 6th. So I'm going to put actually the less than symbol, since this amount on this side is greater than, or I should say this amount on this side is less than. Okay, let's look at the next one. Again, I'm going to put this in scientific notation. I'll write it down here so it's a little clearer to see. So I'm going to move this to the right this time, 1. And remember, when you move to the right, you subtract. I'm going to take 1 away from the exponent. So this new correct scientific notation is 4 and 5/10 times 10 to the negative 11th power. And then over here, oh, it's already in that power, so I'm just going to write it down. So it's in perfect scientific notation. Notice again that the mantisas are the same at 4.5. So this time I'm going to look at the exponents, and I notice that this exponent is negative 11, and this exponent is negative 8. And negative 8 is larger than negative 11, so this one's going to be the greater number. So we're going to say that 4 and 5/10 times 10 to the negative 11th is less than 4.5 times 10 to the negative 8th. And I'll put the symbol up there. Okay, this one we're going to go ahead and we're going to look at the next one. So this one we're going to look at, and I already noticed one thing when I look at this. I have 5 and 65 hundredths times 10 to the 4th. Now this time I have 5 and 6/10 times 10 to the 4th. Well, first glance here, I notice that my exponents are the same, and then I look at my mantissa, and I notice this mantissa is different than my other mantissa. So when I notice that, I'm going to look at place values, and since this is out to the hundredths, I'm going to just make this one out to the hundredths without changing its value. So now when I look at my two mantissas, I can kind of compare better because they're the same amount of digits. And 5 and 65 hundredths is more than 5 and 6 D hundredths, and I'm going to then say that this first amount is greater than the second mantissa, and I only compared the mantissas since the exponents were the same. Okay, and the last problem of these, so notice that this one's already in perfect scientific notation, so I don't have to do anything fancy. I'm going to go with this side, and it's not, so I'm going to work at changing this to correct scientific notation. So I'm going to move the decimal over once to the right, which means that I'm going to subtract 1. So this new amount is 8.35 times 10. Remember, I'm subtracting, so that makes it 7. And this side is 8.35 times 10 to the 7th. I'm going to quickly look at the mantissas. They happen to be the same. I'm going to look at the exponents. They also happen to be the same. So I can conclude that these two problems, or these two scientific notations, are the exact same or equal to. So I'm going to put that equal to symbol. Okay, next page, and you're going to have to look at your paper to do this one. So this one's the one about the pepper heat and how hot a pepper is, or in our case, we're going to look at how much hotter something is. So it says, answer the following questions, put the heat units in scientific notation, solve in scientific notation, and write your answer in correct scientific notation and show all my work. So the first thing I'm going to do is how much hotter. So when you're asking something how much hotter, that is actually a division problem. So all of these are going to be division problems. So we're going to take, in this case, the first one's the mildest ghost pepper. So go ahead and look through your paper and find the mildest ghost pepper. And that is 855,000, other known as 855,000. And that is going to be divided by the hottest cayenne pepper. So I'm going to look at my sheet here, and the hottest, there's two levels, there's 30,000 and 50,000. 50,000 is hotter. So I'm going to put this into the two problems. And now it says though I have to rewrite them into scientific notation. That was my first verb here. So I'm going to write that as 8.55 times 10, and I'd move that decimal over 1, 2, 3, 4, 5 times 10 to the 5th. I'm going to divide that by 5. Let's see how far. 1, 2, 3, 4 times 10 to the 4th. So when dividing in scientific notation, which is your second verb here, we're going to actually divide out. So we're going to take 8 and 55 hundredths divided by 5, and that value is 1.71 times, and then we're going to subtract to remember the exponent. So it'd be 10 to the 5th minus 4, which would be 10 to the 1st. So my answer is 1.71 times 10 to the 1st. And then I'm going to put that back into standard notation because it probably make more sense. So if I actually multiply that out, or in other words, take that times 10 once, this answer would be 17.1 times hotter. So the labels down here would be times hotter. And to me, you can leave it in scientific notation, but sometimes when you take it out in that standard form, it makes more sense to me to know that the ghost pepper is about 17 times hotter than a cayenne pepper, the hottest cayenne pepper. Okay, let's do this again. Let's look at the hottest Carolina Reaper pepper. Okay, so going to my thing. Ooh, that's the hottest one at 2,200,000. And I'm going to compare that or divide it by the hottest cayenne pepper, which was 100,000. So I'm going to change these to scientific notation. So that's 2.2 times 10 is 3, 6, divided by 1 times 10 to the, there's 3, 4, 5. Okay, so to show my work here, I'm going to divide And then I'm going to subtract the exponents, because remember we divide and subtract exponents. So anything divided by 1 is still that value. So this is 2.2. And when I subtract 6 minus 5, that's to the first power. So I can say it's 2.2 times 10 to the first power times hotter. Or I can actually multiply that out so it makes more sense. And so then I multiply it times 10 once. So 2.2 times 10 is 22 times hotter. So both of those could be your answer. Last one for today, the mildest Trinidad scorpion pepper. That's the second to the highest, but we're going to look at the mildest side. So that is 1,200,000. We're going to divide that by the mildest jalapeno pepper, which is 100,000. Let's flip these into scientific notation. So this is 1.2 times 10. Decimals here go 3 and 6. And this is 1, 3, 4, 5. So 10 to the 5th. And then go ahead and divide out. So 1.2 divided by 1, which of course is 1.2. And then times, and then we subtract the exponents. So 6 minus 5 is 1. So it's 1.2 times 10 to the first times hotter. Or if we want to write that out and actually multiply out, that's 1.2 times 10, which turns into 12 times hotter. So we compared two ways. The first way with the symbols less than, greater than, or equal to, and then we compared how much hotter something is by dividing the two values out.